Phones up there, y'all know the drill.
I don't know what you are.
Berkey, if I'm 18, he's, I would forgot.
Just put it down for me, because I'm not gonna look at it now.
I have too many numbers to remember.
Okay, so here's the drill. So some of you had asked about number 15,
Oh, yeah.
okay? So let's talk about this. So here's what's frustrating about number 15. Because of the fact that all it says is that you want to express this in terms of H. And you're going, what does H even mean, okay? So if you look at how like mathematical models are built in physics, you typically have them just in terms of variables. And then once you get that established, then all you have to do is plug in actual measurements. So let me give you an example. So if you look on number 15, the whole key to number 15 is that you're going to drop the ball, okay? I'm going to hold it up, and I'm just going to drop it, okay? I'm not going to throw it down, I'm not going to throw it up in the air, I'm just going to drop it. So because I drop it, what's the initial velocity? Zero. If I throw it, that's not true. So the full-blown equation here is distance equals 1/2 AT squared plus V naught time. Now some of you always make, and I saw this on the assignment that I just gave back, some of you always make V naught time go away, okay? No, you can only make this part of the equation drop out if the object starts from rest. If it's moving, you have to keep this part of the equation here, okay? You only get to drop it out if it starts from rest, okay? All right, in this case it does. So this is not a big dog equation, it's a pup, but it's a handy. So if you solve this for time, you get 2D over A and the square root of that, okay? So this is a cool equation. Because I go, I'm just going to drop it. I know how far it falls. I can calculate the time. Now you have to put it in terms of this equation, okay? So instead of D, you have height, H, okay? I don't know what height H is. I just know it's going to be H. So I'm going to write this as 2H over G. Okay, that's what this is going to represent, right? So if my height is 1 meter, I would put in 1 meter. If my height is 2 meters, I would put in 2 meters. Now, here's where the little bit of algebraic sleight of hand occurs. Could I write this as 2 over G times the square root of H?
Yeah.
Can I do that? Absolutely, I can do that. Okay? I can do that. Now, do you know what the value of G is?
Yeah.
9.8 meters per second squared. You know what 2 is, hopefully. So you could get this number. So somebody get this number. Take 2, divide it by G, and take the square root of that. This is going to be 0 point something.
0.45.
3 significant digits. 0.45.
2.
452 times the square root of H. Okay? So here's where this is cool. So you can plug in any height, 5, 10, 1 meter, doesn't make any difference. It's just going to be the square root of H times 0.452, that's going to get you your time. Okay? If you're into Excel spreadsheets, oh, this would be your Excel spreadsheet. Take 0.452, plug in any value of height, that's going to generate your time. Okay? Now, the next one. Time is still going to equal 2D over G. But instead of D, what are we going to put?
5/8.
Now we're going to put 5H. So that's going to be 2 times 5H over G. Can I do the same thing? What's 2 times 5? 10. So can I write this as the square root of 10 over G times the square root of h.
Yes.
Absolutely, right?
That's perfect, yeah, though.
Now, can I take the square root of 10 divided by g?
Define G first and then you can do
It's 9.8. So somebody give me that number. Take 10 divided by 9.8 and take the square root of that. It's 1 something. Don't forget to take the square root.
1.01.
1.01. So this is going to be 1.01 times the square root of h. So clearly, which ball is going to land first? From h or for 5h?
it.
H. You want to find the difference in times. So what are you going to do?
Subtract them.
Yeah. So you're going to take 1.01 times the square root of h minus 0.452 times the square root of h. That would be the difference in the times. So the only thing that changes is this number here. Okay? That's it. If I said, hey, what if it was 6 times h? Or what if it was 4 times h? The only thing that changes in the process is the number that you get there. Okay, but it's the exact same process. Okay? Cool with that? Fantastic. All right, which other one did you want?
46.
46?
Yeah.
Is that the one with the throwing and the drop? Okay?
Question.
So on 46, what?
So when you subtract them, do you keep the h
Oh, yeah.
variable as well?
Oh, yeah. Because it's a multiple of h. Okay. So on number 46, this is this concept of what I call Jedi Stofel, which stands for stop the force and watch. Okay, kind of the Star Wars reference. Okay? So we'll do this a lot. So if I stop applying the force to this ball to hold it up, so I stop the force and I watch what happens, what does the ball immediately begin to do?
So,
Accelerate, which tells me that there's a force acting on the ball, right?
yeah.
So if I just hold it up and drop it, when I let go of it, what's the only force acting on the ball?
Gravity.
Gravity. What's the acceleration caused by gravity? I'm putting it meters per second squared, right? Now, if I throw the ball up in the air, as soon as it leaves my hand, what's the only force acting on it? Does gravity care that I threw the ball up in the air? Is it going to have the exact same acceleration as if I just drop it?
Yes.
Exactly the same. Okay? Now, what if I'm like, oh, man, I'm having a bad day. It's like, okay? And I throw the ball down. Once the ball leaves my hand, what's the only force acting on it? What's going to be the acceleration? So gravity doesn't care. When we get into talking more about gravity, we're going to talk about the gravity mafia. Okay, so the gravity mafia is always trying to hold you down. The friction mafia is always trying to keep you from like moving forward. Okay, so we're going to be talking about two different types of mafia: the gravity mafia and the friction mafia. So as soon as I let go of the ball, what's the only mafia acting on the ball? Does it make any difference which direction it acts? There's your answer. Okay? Whoever asked about 46. On number 17,
What?
Hey.
Wait,
what?
on 46B, there's, I'm just confused on that.
Look at it from that equation standpoint. Because it's squared, it doesn't make any difference which direction it goes. So there's your hint. Okay, on number 17, this is your elevator problem, and we've got to spend a lot of time talking about elevators. Now, when you get into an elevator, what's the initial velocity of the elevator?
Zero.
0. Okay, hopefully you don't have to jump onto like a moving elevator, which would be cool, don't get me wrong. But that's assuming that this is gonna stop. So you walk in, you're in the elevator. You push the button. What's the elevator gonna do? It's gonna accelerate, right? Gonna accelerate. Might go up, might go down. That's assuming it's gonna go up. So as it accelerates upwards, what's gonna happen to your velocity vectors? They're gonna get bigger or smaller? Bigger. Okay? Now, eventually, what's the elevator gonna do? Is it gonna keep continuously accelerating, or is it gonna reach a constant speed? It's gonna reach a constant speed. So eventually, those velocity vectors are gonna be the same length. Now, you get to the 10th floor, wherever you're gonna stop. What does the elevator then have to do as it approaches the 10th floor? It's gotta slow down. Is it going to accelerate as it approaches the 10th floor?
No. Yes.
Yes,
Oh, wait.
it is. But what's that acceleration gonna make it do? Slow down. Okay? So your velocity time graph is gonna start off here, and it's gonna speed up. Okay? It's gonna speed up. Once it reaches cruising speed, then what's it gonna do?
Flat.
Stay constant.
Be a horizontal line, because this is a velocity time graph. Now, once it goes to stop, what are you gonna do? You're gonna have this, right? Now, pay attention to the instructions on this. I tell you to label the slope of the line. On the test tomorrow, you're gonna draw velocity time graphs. And I'm gonna tell you, label the slopes of the lines, okay? I don't want positive or negative, I want the numeric values of those slopes, okay? Now, so with this one, let me give you a hint. Your total time when you get down to 17D, okay, the total time, accelerated motion, constant velocity. Now, when you're at the constant velocity, bless you, when you're at the constant velocity portion of the elevator ride, what equation can you use? You're only going to use it in one situation.
Adequate?
Nope,
Oh, sorry.
you're at constant velocity. Huh?
Yeah.
Velocity, distance equals velocity times time.
Yeah, distance equals velocity times time, because it's a rectangle, okay? So when you're moving at a constant velocity, you can use distance equals velocity times time, okay? So if all goes well on 17D, that answer should be in the mid-30s, about twice your age, something like that, okay? But that's the total time, okay? That's the total time. Yes?
I'm still kind of confused about the labeled acceleration part, because I know the constant part is going to be, of course, the acceleration it gives us, but I'm kind of confused about when
Okay.
it slopes up.
So, Dylan, what were you told the acceleration is on 17?
It would build up until it's sent to a constant. No.
Dylan,
No,
in
no,
the problem it
wait.
says, what's the acceleration?
It's 2 meters second.
All you have to do is write 2 meters per second squared.
I'm overthinking this.
That's it, that's all you have to do. That's the value of the acceleration. That's it. All you have to,
God bless you.
when it's slowing down, what's your acceleration gonna be?
Negative.
That's all you have to do. That's it, literally, that's all you have to do. Okay, now, let's talk about number 16 with the pyrotechnic shot. Okay? So number 16, here's this mortar, boom, goes up in the air. You need to find the max, or how high it is after 5 seconds. The only way you can do 16A is 1/2 AT squared plus V naught time. There is no other way you can find the height at that point, okay? You cannot use that equation because you don't know what the final velocity is, okay? That's why you can't use that equation Because you can't, well, I'm assuming the flight velocity is 0. You don't know that it explodes at the top of the flight, okay? You just know that it explodes. It could be going up, could be going down, okay? That's why you can't use that equation. So this is a grade equation, okay? It's a function equation. It gives you height as a function of time, okay? Cool with that? Good. So your answer to 16A should be between 100 and 150 meters. It's a pretty good height, okay? Now, on B, to figure out the velocity, the only way you can do 16B, and the only way, is if you use V equals V naught plus AT. You know your initial velocity is 50, you know your acceleration, you know your time. Now, realistically, and again, don't get lost in the minutia. This thing is starting off at 50 meters per second, right?
Yeah.
You know the time is 5 seconds. All you're trying to find is the corresponding y value based upon that slope and that initial velocity, which is your y-intercept, okay? So in a math class, I'm giving you the x value and asking you to find the corresponding y value. That's all it is. So, if your velocity is positive, which direction is the ball going? Up or down? What if your velocity is negative?
Down.
Oh, it's way down. There you go. Your answer to 11, and this is where physics doesn't really match reality. So your answer to number 11 should be around 400 and some change meters per second. Okay? Now, what that is assuming, and physics is famous for this, we leave out things that are annoying. That's assuming,
We have no air.
excuse me, that there is no air resistance. Okay, that's the assumption that this is making. Now, realistically, that's only going to happen in a pure vacuum. But thank God we don't live in a vacuum, because we wouldn't be living if we did. So if you've ever seen the damage caused by a hailstone, terminal velocity of a hailstone is about 20 to 25 meters per second, okay? So if you've seen the damage like a 25 meters per second hailstone could cause at 425, which is faster than the speed of sound, like it wouldn't dent your car, it would go through your car, okay? Like physically go through your car. But the caveat is, if we didn't have an atmosphere, we wouldn't have weather, and we wouldn't have any hailstones to worry about anyway, because there would be no atmosphere to create the hailstones. So, that's the 22. On number 7, both of your answers on number 7 should start with a 3. Okay? Decimal places aren't the same, but both of your answers on number 7 should start with a 3. Your answer to number 9 should start with a 3. Your first answer on number 10 should start with a 3. But the time on number 10 would make it GPA. Okay.
So wait, so the distance
On
starts-
10, the
so-
time would make it GPA.
And the distance starts with a 3.
Yes,
Okay.
distance starts with a 3. Okay. Make sure on number 12, because if your answer to 12A is wrong, everything is going to be wrong. Your answer to 12A should be around the legal drinking age, not what some of you might think it is. Okay? Around the legal drinking age. Make sure on 12C that you have drawn both lines on the same graph. and I see which one is the earth line and which line is the moon line. Okay? Make sure I know which one is which. Okay? Any other questions? Abby?
13.
Okay. Look at every equation that you've dealt with so far. Okay? Oh, come on. V equals V naught plus AT. Distance equals 1/2 AT squared, whatever it is. In every problem that you have done, have I given you the mass of the object? No. That answer your question?
Yeah.
There you go. Dylan,
Number 10 is I'm trying to find.
on the time?
Um, well, I circled 10 to know the question about. I'm trying to remember what it was I wanted to ask about. Well, yeah, what would be the original velocity? I was a little confused on that.
Unless I tell you something differently, you have to assume that it's just dropped and it's going to be zero.
Okay.
Unless I tell you that I throw it up, throw it down, you just have to assume that that initial velocity is zero.
Okay.
Alex?
So I imagine this work is due today?
Actually, here's the story.
Oh, what? Please, money.
Just chill out. So since the test is tomorrow, if you want to hold on to this and hand it in tomorrow, you can. If you're done and you want to hand it in because you're afraid you're going to get pizza stains on it, go ahead and hand it in. Okay? It's purely up to you. There will be no penalty if you hand it in tomorrow. Okay? So if that's what you want to do, that's cool. Okay? It's up to you. Some people are like, hey, I got it, I'm gonna hand it in. Others say, hey, I'm gonna rework these problems. Doesn't make any difference. Okay? Whatever you wanna do. Okay? It's rare that that happens. And I'm only doing this because it's test day tomorrow. So, now, speaking of test day tomorrow, let me kind of explain what's gonna happen. So, this test, you can get it done in the allotted time. Okay, in normal class time, you can get it done, okay? If you want to stay longer, you can, okay? Doesn't make me any difference. I'll be here, because you're from here, you're going into flex anyway, okay? I'm guessing you all aren't on the DNF list, just guess. So, but if you are, and you need to, if I need to, like if you're at May South and you're on the DNF list and I need to email your teacher, flex teacher, and go, hey, Timmy's staying here to continue working on the test, you don't have to drive all the way over there, check in with your flex teacher, and then come back, okay? But you might, if you think because technically you have to check in, so you might tell your flex teacher, if you run into him tomorrow, go, hey, odds are I'm going to be taking the AP Physics test and I might be running late. I'm not going to come back and check in. Okay? So if I need to email, I will. Now, that doesn't mean, hey, we're going to order pizza at 6 o'clock because you're still here. No. Okay? There is a limit to my patience with you working on the test. All right? So just keep that in mind. Here's the other thing. When it comes time for tests, I will only have one person per table. So do rock, paper, scissors, whatever, but there's desks, somebody might have to go to the back of the room, something like that. But it's one person per table. And again, I don't care how you sort it out, flip back and forth, you do this test, I'll do the next test, do rock, paper, scissors, I don't care, okay? So here's what's going to happen tomorrow. I'm going to give you the test. You're going to have a laminated version of this equation sheet. And that's it. Okay? That's it. The beginnings of the test is going to be all multiple choice. Okay? And then you're going to have a couple of big problems to work. The second to the last problem is going to be a rocket problem. Okay? Where rocket's sitting on the launch pad, you fire it up, you shut off the engines, it goes to its maximum height, and then it falls. okay? Which is just nothing but like this, okay? So me throwing this apple in the air is the same idea as a rocket being shot up in the air. This is when the rocket engines are being fired. As soon as I shut off the rocket engines, what's the only force acting on the rocket? What's going to be the acceleration? Right? When it starts to fall, what's the only force acting on it? What's going to be the acceleration? Okay. So here's what we're going to do. The last problem that you're going to have is what's called the ball off the building problem. So what I'm going to do is I'm going to give you all a slip of paper that has the information on it. So here's the short version, is that you are going to be on top of a building. Come on. 8 meters tall. And you're going to throw a ball up in the air, and it's going to come down like this. And I've got all the parameters on here. The initial velocity of the ball is 12 meters per second. So you want to find the time up, the time down, the max height, and you want to figure out how fast it's going when it hits the ground. I promise you, this is going to be the last problem on the test. The only thing I can do on this problem is change the numbers between this and the problem you're going to work on the test. I can make the building taller, I can make the building shorter, I can make the ball go faster, I can make the ball go slower. But it's the exact same procedure. So here's what I'm going to do. I'm going to give you this slip of paper. I want you to treat this like the test. You're not going to hand this in, okay? But this will tell you, hey, am I ready for the test or not? So once you get parts of this done, okay, and you feel good about it, here's what I want you to do. So let's say that Sydney thinks she's got the time up figured out. So here I want 3 things, count them 3. The first thing I want is the solved equation. So she's going to go, time is going to equal, boom, okay? Whatever that equation is. The solved equation. I don't want to see where it starts. I want to end up where you end up. The second thing is that she's going to take that equation and then plug in the numbers with the units. And the third thing is just going to be the answer. So on the test tomorrow, this is the level of detail that I'm going to expect to see, okay? This isn't just getting answers. I'm going to expect to see the equations. Are you consistently using the parameters of the problem? Tomorrow is just going to play out like this. The test tomorrow, the ground is going to be the reference point. Anything going up is positive, anything going down is negative. So, like for example, we need to calculate the time up. We need to get the time down. We need to get the maximum height and the velocity at impact. Now, there are a whole bunch of different ways that you can work this problem, okay? Probably 12 different combinations on how you work this problem. There isn't one that's, oh, this is the best way. It just has to make sense to you. So I'm going to give you this. Shut off that camera. So when you think you're ready, you come up, the solved equation, the numbers,